Right. So in this worksheet, we're going to talk about mass to mass stoichiometry. The map is the same thing, but this time we're going to predict product. Now, predict product, we only have three kinds: double, single, and combustion. So then the notes here are not something new. Well, whenever we have the double displacement, all the soluble will be aqueous. Just like look up, let's see, you want to look up this solubility chart. Okay, anything aqueous, okay, will be soluble, will be aqueous, no matter reactant or product, aqueous. If it's like insoluble reactant, will be solid. Insoluble product will be PBT. We all know that. Okay, we all know that. So it's not something new. But then for single displacement, everything aqueous will be soluble. And then if the reactant for product, if they're insoluble, we use solid. And then for the combustion, CSHY or CSHYOH, the X between 1 to 4 will be gas, liquid will be 5 to 14, and solid will be more than 15. So this is not something new. Now your map part is the same thing starting number 3. But since this is a predict product, you have to guess a couple of things. First of all, you have to recognize if you have any 7 diatomic elements. Now the 7 is H2, N2, O2, F2, Cl2, Bl2, I2. You don't have to memorize them because they are on the periodic table, like a 7. Okay, and then plus the H2 here. All right, so if you are giving like fluorine, you don't want to write F, you should be write F2. If you're giving hydrogen, you don't want to write H, it's going to be H2. And the first 5 will be gas, and then Bl2 will be liquid, and then I2 will be solid. So in this example, you will be just giving like, oh, how many oxygen are needed for combustion of tricarbon octahedride. That's all you're given. So you know that these two are the reactants. So then you predict the product because it's a combustion. You know how to predict the combustion product, also CO2, H2O. And based on the type of the combustion, you get a balanced equation, and then you do the math. So here I'm focusing on the equation, the predict product part. So the number 2 here. Right? How many grams of solid iodine will be formed when 325 grams of liquid bromine we add with aqueous aluminum iodide? Now, solid iodine will be formed. That means it is a product. If it's a product, it will be on the right-hand side of the equation. Okay? Liquid bromine we add with aqueous aluminum iodide. So because they are reacting each other, so these two will be reactants. That means they will be on the left-hand side of the equation. Okay? So we can start to write. So I'm going to rewrite here. Okay, so we know that the liquid bromine, okay, liquid bromine is going to be Br2. Okay, it's not Br, right? Because we say that it's diatomic. And even though I did not tell you that it's a liquid, you should figure out the state is that it's a liquid. Okay, and then it say we add with aqueous aluminum iodide. So aluminum iodide, aluminum is the metal, so that's why it is an ionic compound. When it's ionic compound, we need to cross over. So you can actually do the crossover outside the other piece of paper. So aluminum is Al3 plus, iodide is 1 minus. When you cross over, you will get Ali3. Okay, you get Ali3. So Ali3. Okay, and then by the solubility chart, you look like, okay, iodide is going to be soluble, no exception, right? So then it will be aqueous because it's soluble. Now, even though I did not give you the aqueous, you should figure out the solubility. Now, do I need to show the web here? You don't have to, but if you don't know, you're not sure, I strongly recommend you to do the math on the side, because like sometimes you have to, like, you don't remember if it's ionic or covalent, you gotta form the compound wrong. So you don't have to show me this, but you can do it on separate paper if you cannot figure out. Okay, and then the sodium, the iodine is a solid. Okay, it's a solid, it's a product. Now iodine is a diatomic, so we don't want to write I, we gotta write I2. Okay, it's a solid. Now you can tell that, hey, you know that your reaction is not done, because if you go into balance, you find out that I'm missing something. So actually this equation is not completed. That's why you have to predict product. Now, if you look up the reactants only, my predicted product must be either combustion, single displacement, or double displacement. So obviously, this is single displacement because it's aluminum compound. So single displacement, you're gonna look up this as like a hint if you forget. If you forget, you can go ahead to draw the arrow, go ahead to draw the rainbow. If it's double displacement, you're gonna use this sign, okay? And the single displacement, the key sentence is, lonely kick the happy out. So this is lonely, this is happy, right? So we're gonna consider, right, this one, okay? So this you don't have to check because I formed the compound, so you don't have to check the table, you don't have to check the which one's going to be on top or on above. You don't have to because I already tell you that the reaction takes place. But on the other hand, you should recognize how to write this kind of word. You should remember how to write this kind of word if you don't remember. So the I2 is actually going to be kicked out, right? So we first want to rewrite. We've got to separate the couple first. We've got to separate the dancing couple. So originally, all right, ALI3 originally is AL3 plus I1 minus. I just separate them. Okay. Now remember the single displacement. Once you separate them, the one that we don't touch, we save it there. The other one, we underline that. They're gonna change the identity. So for example, here AG plus will change to AG, MG will change to AG, MG2 plus. We're gonna use this. Okay. So the same thing as here. We're gonna change only the underlying one. Okay. So the AL3 plus stay there. Now the underlying one is I1 minus. I1 minus gonna change to I2 because, right? I minus gonna change to I2. It must be either that, no other choice. Okay, and then BR2, we gotta switch that to BR minus. Okay, so BR2, we gotta switch it to BR minus. Okay, so then the I2 get kicked out. In the past, we write that at the end. Right now, since I was given from the question, I write the I2 in the front. Honestly, it doesn't really matter. But in the past, we say we gotta kick the I2 at the end. And then the AL3 plus, and then the BR minus gonna be in the cloud, and they cross over, we'll get ALBR3, and then if I check the solubility, it will be aqueous. Now this is not something new, we did that before. The only thing is like these two, like we switch the order at the beginning, we say, oh, the I2 is gonna kick at the end. But since the I2 was given in the question, we write along here. So this is not something new, you did that before, predict product. So if it's a double displacement, you gotta follow that. All right, double displacement. If it's a combustion, you remember how to predict the product for combustion. And then after that, we gotta balance them. We have 3, 2, 3, 2. Okay, and then we gotta do the same thing as mass and mass number 1. So we were given 300.25 gram of bromine. So we write that down on the bottom, and then we find the honey will be MM of BR2. We're looking for iodine product, the gram, so we put a question mark on it, and then we write down the MLI2. So then we draw the map from what we given to what we trying to find. So we get this direction, and then we label 1, 2, 3, 4. Then after that will be the same thing as the mass to mass product.